not. Okay, let me show you what was going on there and how I would maybe just adjust a little bit, because the beginning sounded really good. It sounded like you were bang on. Essentially, you've got 6 boxes, right?
Yes.
And what we're being asked to calculate is the probability that you pick 2 boxes and have the same prize in them. Is that correct? Right, so let me double check on this. Can you remember if this is intro to probability A or B? Can you remember which one this question came from? I'm checking the answers. Okay. Yeah, I got it. Yeah, I got it now. Okay. So you're looking for what's the probability that they pick the same prize, right? So I think of it's a little bit subtle, but I'll try and imagine. Can we call these prizes A, B, C, D, E, and F? That way we kind of think you work with, right?
Yes.
And so if you got both prizes the same, these would be the events that would generate that, right?
Yes.
Like you get, okay. Now, the probability that you get A in the first box and A in the second, we'll use the multiplication rule of probability. So there's a 1 in 6 chance that you get the first one as A, and there's another 1 in 6 chance that you get the second one. And so that guy is 1/36. And if I go to the last one, the probability that that happens, it's also 1/86 times 1/86 and 1/36. In fact, all of these have the same probability. They all have the probability of 1/36. So the probability that they're both the same is what you get if you added all of these together. So you'd take the first answer and you'd add the second one and you'd finish with the last one. And since they're all the same, and there's 1, 2, 3, 4, 5, 6 of them, that would be 6 lots of that guy, which is 6 out of 36, which ends up being 1/6. So the probability that you get both of the same is 1 out of 6. And that's how you should have approached that question.
But why you think the possibility need to add them together? I'm lost
Well,
there.
right. Well, when you say the probability that both of them are the same, that's just like me saying, what's the probability that they were A's, right? Or they were both B's, or they were both C's, or blah, 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 blah. I don't want to write the whole thing. Or they were both F's. And when you have...
Oh, I see. I see. There's no overlap.
There is no overlap, exactly.
Okay, I see.
So you're just basically adding 6 things together that all happen to be the same thing. In this case, 1/36. Now, the probability that they're both different is actually very easy to calculate. The both different is the complement of both being the same. Complement just means the exact opposite. So if you look at the situation, if you pick 2 prizes, there's only 2 real big groups of things that can happen. Both prizes are the same, or they're different. If I know there's a 1/6 probability that they're the same, then the difference, right, the other ones, is what's left.
I got that part.
Okay, and that's where the 5/6 comes from.